Welcome back. Problem 14-11. This problem is taken from chapter number 14, Energy Methods, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the bending strain energy in A-36 structural steel W10x12 beam. Obtain the answer using the coordinate x1 and x4 and then x2 and x3. So you can see this is the beam W10x12. At this point there is a pin support. At this point we have a roller support, and at this end we have 6 skips load. Clear? The total length of the beam is 18 feet. Clear? So from the table, mechanical property for A-36 steel, E is 29 into 10 to the power 3 ksi, and from wide flange section table, I moment of inertia for this is 53.8 inch power 4 for this beam. I will show you it later. So we have to determine the bending strain energy using x1 and x4 and x2 and x3. So let's start with the solution. So what will be the first step is that if you remove this pin support, so you'll be having reaction force. Let this is your point A and this is your point B. So the vertical reaction, and there will be horizontal reaction. Clear? So if you remove this roller support, so you will be having reaction force that will be upward. Why upward? Because you can see 6 skips is downward, so this will be upward. Let this is RB, and this vertical reaction force at RA will be downward. So this is RAY, and this will be equal to RAX. So you will find this RAX, RAY and RB by using equation of equilibrium. So what will be the equation of equilibrium? So first equation of equilibrium is that sum of all movement about point A is equal to 0, and taking the counterclockwise movement as positive. So you can see this length is 12 feet. So in inch it will be 12 by 12 inch. Clear? That will be equal to 144 inch. Clear? And this 6 feet will be equal to 6 multiplied by 12, which is equal to 72 inch. Okay. So sum of all moment about point A is equal to 0. So first moment will be this RB into perpendicular distance is this one, and this is producing counterclockwise movement, so it will be positive. So I will write RB multiply by 12 multiply by 12. Clear? The second moment is due to this 6 skips load, and the perpendicular distance is 18 feet. So I will write 18 multiplied by 12, that will be converted into inch, and this is producing clockwise movement, so it will be negative. So I will write minus 6 multiplied by 18 multiplied by 12 is equal to 0. So from here this 12 multiplied by 12 times RB is equal to 6 into 18 multiplied by 12. Okay, so this 12 RB will be equal to 6 multiplied by 18. So from here you will get RB is equal to 6 multiplied by 18 divided by 12, and you will get this RB will be equal to 9 kips. Clear? Okay. This will be RBY because this is the vertical component. Okay. So RBY is 9 kips. Now we'll find this RAX by using this equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right direction is positive. So there is only horizontal force RAX, there is no other force, so it means that RAX will be equal to 0. Now we'll find this RB by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So from here RAY, which is equal to, which is not known, so RAY which is minus. Clear? Okay. So RAY which is minus plus RBY which is 9 kips minus 6 is equal to 0. So it means that RAY is equal to 3 kips. Okay. Now you have all these reaction forces. So we will move toward finding bending strain energy. And we know that bending strain energy is equal to integral of m square dx over 2ei, and it is from 0 to length L. So what we are going to do is that first we will solve this by using x1 and x4 coordinate. So for x1 we will cut the beam over here and we will draw the free body diagram. So for x1 coordinate, I cut the beam and draw the free body diagram. Here you can see you have RAY, which is 3 kips. Clear? This coordinate is having length x1, and when you cut it you will be having a shear force V1 and there will be a bending moment M1. That this is your point 1. Now applying equation of equilibrium, that sum of all moment about point 1 is equal to 0, taking the counterclockwise moment as positive. So we will need this bending moment because we will use it in this equation. So 3 into perpendicular distance about point 1 is x1, and this is the moment which is positive. So 3x1 plus m1 is equal to 0. So from here we will get m1 is equal to minus 3x1. This is the moment equation for coordinate x1. Now what we will do is that we will do for coordinate x4, because in first part we have been given for x4. So x4 is this one. So we will cut the beam over here and take the right side in order to draw the free body diagram. So I will draw the free body diagram. It will be like this. You can see at this end we have 6 skip load. This is x4. Clear? So when you cut it you will be having shear force upward. Here this is V4 and there will be a moment M4. Let this is point 4. So how we will find this M4? By using equation of equilibrium, that sum of all moment about point M4 is equal to 0 and taking the counterclockwise moment as positive. So this force 6 into x force is producing moment about point 4, that is clockwise, so it will be minus 6x4. So minus 6x4 plus minus this m4 is equal to 0. So from here you will get m4 is also equal to minus 6x4. Now you have both the moments. So what we are going to do, we will put it in this formula. So let's put it. So we know that strain energy due to bending moment is equal to, for coordinate x1, you can see its length from 0 to 144 inch. For x coordinate 1, x1 0 to 144 inch. Clear? And for x4 it is from 0 to 72 inch. So we will put the value of m1. m1 is minus 3x1 square into dx divided by 2ei plus integral of from 0 to 72, and m4 is minus 6x4 whole square dx divided by 2ei. Now what you can do is that you can take 1 over 2ei common because they are constant. So we're left with integral of 0 to 144 minus 3x1 square dx plus integral of plus 1 over 2ei into integral of 0 to 72 minus 64x4 square into dx. Not minus 64, minus 6x4. Okay. So this will give us 1 over 2ei, and that we will get 9x1 square integral of 0 to 144 dx plus 1 over 2ei integral of 0 to 72 36x4 square into dx, and that we will get 9 over 2 ei integral of x1 square will be equal to x1 cube over 3, and limit will be from 0 to 144. Similarly, 36 over 2 ei and integral of x4 power square will be x cube 4 over 3, and integral from 0 to 72. So at the end, when you calculate it, and you can put the value 9 over 2 ei into 144 cube over 3 plus 36 over 2 ei into 72 cube over 3. Now you have the value of E and I, so 2 divided by E is 29 into 10 raised to power 3 ksi. I is given as from the table 53.8 multiply by 144 cube over 3 plus 36 over 2 times 29 into 10 raised to power 3 divide by multiply by 53.8 into 72 cube over 3. That will give you strain energy due to bending for coordinate x1 and x4. So when you solve this ui strain energy due to bending moment, that comes out to be 4.31 kips into inch, which is the answer of our first part. Now in part B, it has been asked to find the strain energy due to bending for coordinate x2 and x3. So for that, you can see x3 is here. So we will cut the beam over here, and we will take this as left side as a free body diagram, and to find the moment m3. So for that, I will draw the beam free body diagram of the beam. So you can see this is point A, so where you have the vertical reaction 3 kips downward. Clear? This is your point B, so where you have RBY, which is upward, and RBY is 9 kips. Clear? This total length is 144 inch, and this is the coordinate x3. So when you cut it, you will be having a shear force V3 downward, and you will be having a moment M3. That this is your point 3. So we'll find this moment by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point 3 is equal to 0, and taking the counterclockwise moment as positive. So about point 3, one moment is M3, which is counterclockwise. So I will write M3. The second moment is this 9 into perpendicular distance is 3, and this is also this is clockwise, so it will be negative. So minus 9 into x3, and the last moment is due to this 3 kips load, and perpendicular distance is 144 plus x3, and that will be clockwise, counterclockwise, so it will be positive. So I will write plus 3 into 144 plus x3 is equal to 0. So m3 minus 9x3 plus 3 into 144 will be 432 plus 3x3 is equal to 0. So m3 is m3 minus 6x3 plus 432 is equal to 0. So from here, this m3 will be equal to 6x3 minus 432. So this is the moment equation for coordinate x3. Now what we are going to do is that for coordinate x2, we will cut the beam over here, and we will draw the free body diagram of this right hand side to find the moment for coordinate x2. So for coordinate x2, So when you cut it over here and draw the free body diagram, so I will draw it like this. You can see this is 6 skip. There, this is point B where you have 9 kips load. The length, this is 72 inch there, and this length is x2, which is coordinate x2. So when you cut it, you will be having a shear force which is V2, and you will be having a moment M2. Let this is your point 2. So we'll find this M2 by using equation of equilibrium, that is sum of all moment about point 2 is equal to 0, and taking the counterclockwise moment as positive. So about this point 1 moment is M2, which is clockwise, so I will write minus M2. The second moment is due to this 9 kips load and perpendicular distance is x2, and this is producing counterclockwise, so it will be positive, so plus 9x2. And the last moment is due to 6 and perpendicular distance is x2 plus 72, and this is producing clockwise movement, so it will be negative. So I will write minus 6 into x2 plus 72, and the sum of all moment about point 2 is equal to 0. So from here m2 plus 9x2 minus 6x2 minus 432 is equal to 0. So minus m2 plus 3x2 minus 432 is equal to 0. So m2 will be equal to 3x2 minus 432. This is the bending moment due to coordinate x2. Now you have this and this. So what we are going to do, you know that strain energy due to bending moment will be equal to, for coordinate x2. x2 you can see start from here 0 and till 144 inch. And similarly x3 start from 0 to 72 inch. So for x2 0 to 144, the equation was m square m2 square dx2 divided by 2ei plus integral of 0 to 72 m3 square into dx3 divided by 2ei. Now you can put the value. So I will put the value 0 to 144, m2 is 3x2 minus 432 square into dx2 divided by 2ei plus integral of 0 to 72, m3 was 6x3 minus 432 whole square dx3 divided by 2ei. Okay, so you can take 1 over 2ei common from both, so 1 over 2ei, and we will left with integral of 0 to 144 3x2 minus 432 whole square dx2 plus integral of 0 to 72 6x3 minus 432 whole square dx3. Now we will apply the square formula, so you will get integral of 0 to 144, so 3x2 whole square will be equal to 9x2 square, 9x2 square plus 432 square will give you 186624 minus 2 times 3x2 into 432 will give you minus 2592 x2, and that will be dx2. Clear? Plus integral of 0 to 72 6x3 be 36x3 square plus 186624 will be the square of 432 minus 2 times 6x3 into 432 will give you minus 5184. 5184 x3, and it will be into dx3. Okay, so now this is very easy. You can just put the value, you can take integrate it. Okay, so 1 over 2 ei, this will give you 9x 3 cube over 3 in limit from 0 to 144 plus 186624 x2, not 3, this is x2, x2, and limit from 0 to 144 minus 2592 into x2 square, and limit from 0 to 144, x2 over 2, this will be 2, clear, plus 36 x3 cube over 3, and limit will be from 0 to 72 plus 186624 x3, and limit will be 0 to 72 minus 5184 x3 square over 2, and limit will be 0 to 72. Okay, so now you can easily solve it. You can just put the value. So I will put 1 over 2e is 29 into 10 raised to power 3 ksi. I is 53.8. You can check it over here. Clear? And you can put all other values. 9 multiplied by 144 cube over 3 plus 186624 into 144. Clear? Plus minus 2592 into 144 square over 2 plus 36 into 72 cube over 3 plus 186624 multiplied by 72 minus 5184 into 72 square divided by 2. And when you solve all this, you will get strain energy due to bending moment of coordinate x2 and x3 comes out to be 4.31 kips into inch. So this is the amount of strain energy that will be stored due to bending moment for coordinate x2 and x3. And that was all about this problem 14-11. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help me in growing my channel further. Thank you for watching.